This video is on applications of the V equation for kinematics. We're going to be doing some simple problems that apply the V equation. If you have not watched the concepts video for the V equation, you may want to do that first. Suppose we have a truck traveling at 30 meters per second, which is going to accelerate at a rate of 1.2 meters per second squared for an amount of time of duration 3 seconds. And we want to know the velocity of the truck at the end. Well, velocity of the truck at the end, that's very obviously our VF concept. Traveling at 30 meters per second and begins, that's talking about the beginning, so we know that's V initial. Acceleration is clearly labeled as 1.2 meters per second squared. That's next to the word accelerate. We know that's going to be A. Time of duration, 3 seconds. That's obvious as well. We're just going to plug those numbers in to the correct parts of the equation. And the unknown, VF, for us, we're going to leave it as a variable. And then we're going to do our arithmetic. And we're going to multiply these numbers, add them to 30, and we're going to find that our final velocity for our truck is actually 33.6 meters per second. And that's how we do that. Another example. We're going to change the unknown, and we're also going to use a negative for the acceleration this time, which means we're going to be slowing down. Suppose we've got a kangaroo hopping at 12 meters per second, which begins to accelerate at a rate of negative 3.6 meters per second squared. Again, that means we're slowing down. How long does it take the kangaroo to come to a stop? Well, we know by looking at this, again, 12 meters per second, that's at the beginning, that's our initial velocity. We're talking about acceleration here, that's going to be A, that's our negative 3.6 meters per second squared. How long, that's our question now, that's delta t, that's going to be our unknown. Does it take the kangaroo to come to a stop? Come to a stop, well, it doesn't spell this out for us, but we know if anything is coming to a stop, that means the velocity at the end of the process is going to be 0. That's what stopping is. That's bringing the velocity to 0. So now we can plug those numbers into the appropriate places in the V equation, and the unknown we're going to put in its place. We're going to leave it as a variable. So now we've got 0 meter per second equals 12 meter per second plus negative 3.6 meters per second squared, that's our acceleration, times delta t. We do the algebra, we solve that for our unknown, and we are going to find that delta t is equal to 12 meters per second divided by 3.6 meters per second squared. Meters on top and bottom is in the numerator of both, that's going to cancel. Seconds is in the denominator on top and on bottom. It's squared on bottom. That means we're going to lose the square on bottom and we're going to lose the seconds altogether on top. We're going to be left with seconds in the denominator of the denominator for the unit. Denominator of a denominator floats to the numerator, and when we do this math, we get 3.3 and the unit is seconds. That's rounded to 2 sig figs. So that's a little bit about the V equation. I hope you enjoyed this video. If you are interested in physics or math tutoring from yours truly, please feel free to check out my website. The link will be in the description for the video.